All right, if I ask you to solve this equation, you can put this on the top, on the side, on the bottom corner, I don't care. Or if I ask you to solve this equation, you can put this on the top, on the side, on the bottom, I don't care. What would you do? Say neighbors. Sorry, thing, but you'd be wrong.
I know. I'm trying to think. I don't know how to do it. I'm just trying to think about how to do it.
He doesn't know how to do it.
No, I do. We're all
What did you say? Divide by x?
No, you do the little x.
We factor. We factor out a greatest common factor. Okay, what are the solutions to the one on the left?
2x.
Negative a half. We have a product set equal to 0. We set both pieces of our product equal to 0. We solve both pieces of our product equal to 0. Using the zero product property, we get two solutions. This one, I don't want you guys to use, sure, use x if you want to. Just don't screw it up. You should know that x plus some value times x plus some other value distributes to be x squared plus ax plus bx plus ab. You should know how to distribute. So that you should know the a and the b will be added together to get the middle term. The a times the b get multiplied. So you're looking for two numbers that add to get -1 and multiply to get -2. Those two numbers are -2 and +1. And then you solve using the zero product property, the answers for x that will make the left side equal to 0. We do not divide by x's. We don't divide by x's because we would remove potential solutions, like x equals 0 could be a solution. If I divide by x here, a lot of people do this. They have 2x squared equal to x, and they're like, oh, I can solve this. I'm going to divide by x. And they say 2x equals 1, x has to equal a half. Yeah, that's one solution, but another solution is x equals 0. So we never divide by x's, okay? We look to factor. Why do I say this? Because this equation right here is in the form of 2 times something squared plus that same thing, or like 2x squared plus x equals 0. This question right here is in the form something squared minus something minus 2, or x squared minus x minus 2 equals 0. We'll use the same techniques to solve these equations. We will look to factor to solve. What would that look like, do you think, up here? Go ahead and do it. Tell your neighbors. Now, again, we don't subtract sine x and divide by sine x. That's not correct. You can't divide by x's, so you can't divide by sine x's, or solutions will disappear. What would it look like to factor this? You don't factor out x, you factor out sine x. Now, sine x gets factored out of these two terms, leaves you with 2 sine x plus 1 left over. Now what do I do? Tell your neighbors. Not divide by. That was funny now. You You got me. That was good. That was good. We take the pieces of our products and individually set them equal to 0. That means like we use the 0 product property, but instead of like that example with x's, where our solutions were just like known, you guys are like, oh, x equals 0, x equals -0.5. Instead, we have to do a little bit of work. We're going to have to figure out when to sign equals 0 and when we'll sign x equal -0.5. And then we find all of our angles that would either solve this one or solve this one. What are all the angles when sine x equals 0 and sine x equals -0.5? Write them down and check with your neighbors. Okay, sine x equals 0. At the horizontals, so that's x equals 0, pi. I'd write 2 pi as well, but we want to exclude 2 pi because it's coterminal to 0. And then we have when sine equals 1/2 at the pi over 6's, sine is negative in the 3rd and the 4th quadrants. So I want this pi over 6, I want that pi over 6. Those pi over 6's are 7 pi over 6 and 11 pi over 6. Okay? And boom, we see there's actually 4 angles between 0 and 2 pi that would solve this equation. Okay? Go ahead and try this one out for size. Go. Here's the words of wisdom. Replace tangents with like x. You know, like see what the equivalent form would be so that you're comfortable factoring said equivalent form. Like, can you factor 4x cubed plus 4x? Yeah, I can. Go ahead and try it. Yeah, make this a minus. Yeah, make it a minus. There's a reason why I made it a minus. All right, I would factor out 4x, giving me x squared, and this is a minus. Thank you. So that is equivalent to factor out 4 tan, leaving us tangent squared x, and I changed the question to a -1. Now, 2 equations that we have to solve. 4 tan x equals 0. Well, now I can divide by 4. Dividing by a number is fine. Don't divide by x. When does tangent equal 0? Again, at the horizontals, when your sine is 0 and your cosine is 1 or -1. 0 pi, 2 pi. I'm not going to include 2 pi because it's coterminal to 0. We were told not to. Then on the other side, this is when I have tangent squared x will equal 1. After adding 1 to both sides, I'll square root both sides to get plus or -1. When does tangent equal 1? When the OA equals 1. All the pi over 4, bro. Pi over 4, don't say 2 pi over 4. 3 pi over 4, don't say 4 pi over 4. 5 pi over 4, don't say 6 pi over 4. 7 pi over 4. Boom. Every single one of these angles will make that left side 0. We go to the next guy. Secant squared x minus secant x minus 2 equals 0. Its equivalent form is like x squared minus x minus 2. How did you factor x squared minus x minus 2? It's the two numbers that multiply and add. Go ahead and see if you can factor secant squared x minus secant x minus 2. For this equation, we look for x plus something times x plus something equals 0. The somethings are a negative 2 and a positive 1. But it's now secant x minus 2. Secant x plus 1 equals 0. We have a product set equal to 0. We set both of those terms equal to 0. We solve, which means I need to find when secant x minus 2 equals 0. That's when secant x equals 2. Solve that for me. I need to find when secant x plus 1 equals 0. That's when secant x equals negative 1. Solve that for me. We immediately take the reciprocal of both sides, and this is cos x equals positive 1/2. This is cos x equals negative 1. Oh, no, it's fine. If you are to factor x squared minus x minus 2, you don't factor out an x from these two. This is the product of x plus a number times x plus a number. You know, like if you multiplied this out, you get x squared, you get 1x, you get negative 2x, and you get negative 2. That's that. A lot of people like to use this little technique, which I don't like to use. I like, yes, so you use that, okay? No, you're told to find them in this interval. Okay, so we get the 2 times cosine equals 1/2. Cosine in the equaling 1/2 is the tall 30, 60, 90 triangle in the first quadrant, and the fourth quadrant is where cosine is positive. So that's pi over 3, 5 over 3. You're copying this down. It's not worth anything to you. And then when is cosine equal to negative 1, that's pi. Guys, copying notes down does nothing. If you copy notes down, you are not learning anything. You're just copying. Please try things. That's how you're going to learn to do. Don't divide by sign. Don't keep the 5 over here. If you ever had x squared plus 4x equals 5, what do? Subtract the 5. Linda, put your phone on my desk over there. Over there. I don't want to see your phone. I want to see your phone on my desk at the beginning of next class as well. And probably the next class. Great. We subtract 5 from both sides. We get it equal to 0. What do we do here? Subtract the root 3 sine x. Don't divide by the sine x. All of a sudden, valuable solutions will disappear. Ooh, that's 2 sine x cos x minus root 3 sine x equals 0. Guys, your first 2 pages of your homework are like finding intersections. It's really just factoring. Okay, it's factoring, factoring, and more factoring. You have to practice. You have to practice. Here, if I gave you this equation, could you factor and solve? Now it's got sines and cosines. And whenever it has sines and cosines, well, maybe we consider just thinking about an x and a y. I got 2xy minus root 3x. If I asked you to factor this, could you factor 2xy minus root 3x? Tell your neighbors. What would you factor? Factor out an x, right? You could take out an x, and you got 2y minus root 3, right? Guys, you got sines and cosines, right? Well, you could factor out sine from both of those terms, and that's what you're going to do. Factor out a sine. You have 2 cos x minus root 3 equals 0. Now you could solve. Now you can solve. Good. Now, this turns, stop talking. You guys were all whining about how hard the quiz is today. And now you're showing up to this lesson being like, oh, whatever. Like, lock in, please. 2 cos x minus root 3 equals 0 turns into cos x equals root 3 over 2. Sine equals 0 at 0 pi 2 pi. Cosine equals root 3 over 2 at pi over 6 and 11 pi over 6. How do I know that? Not because I've memorized, because I figured it out. Don't copy it down. It's worth nothing. Stop copying things down. Do it. Go to the next page. Okay. What should we do first here? You are not allowed to factor out the t. Subtract 1, great. Just wait. You don't know what you're doing. You're gonna figure it out after I teach you the next thing. Do you know what the identity is? All right, good. Okay, now I got sines and cosines. Cool. I had sines and cosines the last time. Didn't stop me. But here's what I would write down, maybe so I understand the equivalent form. X squared plus y minus 1 equals 0. Uh-oh is right. Do you know how to factor x squared plus y minus 1? No. You can't factor that as you see it. So we need more. We need to potentially change this, rewrite this. We need to substitute potentially. No, we need to substitute something potentially, rewrite this equation, and then solve. And here's what we're going to substitute with, Mansky. Something that we've already known, but we haven't seen in this form before. Do you guys know the thing called the Pythagorean theorem? Do you know the Pythagorean theorem with the right triangle? What's the Pythagorean theorem? Tell your neighbors what the Pythagorean theorem is. Very good. Very, very, very famous theorem. Who knows if the Greeks were the first ones to find it? Probably not. But it said that the squared sum of the leg's length equal to the square of the hypotenuse. Cool? Everybody good with that? Well, now let's put that right triangle in our unit circle. Okay? Just like we've been doing. Gosh, what do I have to do? What do I have to do? Ford. What do I have to do? What do I have to do? Got to do a little square on the bottom? All right, fine. I'll do a little square on the bottom. All right. Let's put our right triangle in our unit circle like we've been doing for the last couple of units. There's one side length you know. The hypotenuse is 1. Good. Very good. All right. So, we also haven't been using A's and B's, right? What have we been using for our side lengths in our, well, if it's a 45-45, it's root 2 over 2. If it's a 30-60-90, it's root 3 over 2. But, Clam, we've been using like an x distance. Our adjacent's always an x distance. That ends up being like an x coordinate on the intersection with the unit circle. Or y, we call it a y coordinate. So we've said that, okay, we got x, y, and 1. The Pythagorean theorem would be x squared plus y squared equals 1. This is our unit circle Pythagorean theorem. But if we think about SOHCAHTOA, x is always equal to what? The adjacent, the cosine of the reference angle. Okay, we're going to throw in a little angle. Here's a little angle. The cosine of my angle equals x over 1, which is x. The sine of my angle equals y over 1. I am going to start with my unit circle Pythagorean theorem. And then I will change it to a unit circle Pythagorean theorem with an angle being referenced. You must know this. Can it be memorized? Sure, it can be memorized. However, if you know where it comes from, I think it might stick with you a little bit longer. Where does it come from? Tell your neighbors. What did I just show you? It's the Pythagorean theorem in our unit circle talking about angles. It's the unit circle version of the Pythagorean theorem. You nailed it. Okay? Now, my friends, we typically write this as sine squared theta plus cosine squared theta equals 1. So we usually put it as y squared plus x squared equals 1, even though you guys probably like x squared plus y squared equals 1. That's just like the more common form. Now, just like any equation, it can be manipulated to help us. Sine squared theta plus cosine squared theta, the unit circle version of the Pythagorean theorem referencing angles. You could do whatever you want to it. For example, could you say, solve for sine squared? So let's come back down here. You see that sine squared? Could I potentially take this equation and solve for sine squared? Tell your neighbors, what would sine squared equal? Very good. You could subtract cosine squared, and all of a sudden, another version of this is cosine squared. Sorry, sine squared equals 1 minus cosine squared. You could also solve for cosine squared. How? You subtract sine squared. It's all equivalent forms of the same equation. These are not memorized. These are not known. You start with this, because the Pythagorean theorem is known, the Pythagorean theorem is understood, and then you know how to manipulate. Now, how can we use this to our advantage? Well, come back up here. You now can replace sine squared with what it's equal to. So please do that. Don't copy what I'm about to write down. You do it. Replace sine squared with what it's equal to, or substitute. It is 1 minus cosine squared. You can use sine squared plus cosine squared equals 1 as a little like shortcut. And then you'd be like, okay, I want sine squared. Sine squared equals 1 minus cosine squared. So you're like, okay, I'm going to replace this with 1 minus cosine squared t.
Well, cosine doesn't make squared 9.
Great. We have a positive 1 and a negative 1 all of a sudden disappear. You now have negative cos t plus cos squared t plus cos t equals 0. You've just changed this equation, which is like confusing and can't be factored, to this equation, negative y squared plus y equals 0. And you can factor that. You can factor out the y, you can solve, and I'm going to leave the rest of that to you while you do your homework. And again, guys, this is an easy homework to copy down your answers on Mr. Huffaker's video because I don't have time to make it. You got to do it. Okay? You got to do it. Okay. Now, this is the exact same thing, but what would you look to do in this situation? Now, really quickly, there's a different prompt. Find the values for x when this function is equal to 0. All right, no big deal. Cos squared x plus sine x plus 1 equals 0. What would you think to do here, guys? Tell your neighbors, what would you think to do? Everybody try. So what will always help you is having a little shortcut Pythagorean theorem in the unit circle, sine squared plus cosine squared equals 1. You are finding what cosine squared is equal to. You subtract sine squared. Okay, you're like 1 minus sine squared is the same as cosine squared. So I got 1 minus sine squared x plus sine x plus 1. Same kind of deal. We then add the 1. Ooh. Got plus 2. Now we got to factor something that looks like negative x squared plus x plus 2. Again, this is not something you can just show up on Wednesday and be able to do. You will need to practice. Maybe dividing everything by a negative 1. Factoring so you know that it's sine x minus 2. It's actually, yep, sine x minus 2, sine x plus 1. Setting up two equations, sine x equaling 2 and sine x equals negative 1. Sine x can't equal 2. Max value is 1. So no solutions come from that. Sine x equals negative 1 at 3 pi over 2. What?
It's negative 1 and negative 1.
No, negative 1 times negative 1 is 1.
Yeah.
So no, you're wrong.
But that's it adds to multiply.
Can you do me a favor really quickly? What's just like by yourself? Can you multiply x plus 1 and x plus 2 together? Can you just go ahead and multiply that for me? What is it? Just multiply it out for me. You got it? You got it? We good? Yeah, so that's why we don't memorize the x. We instead like know what to do. Okay. Now let's go to the next question. What? So the biggest value of sine is 1. Sine's maximum value is 1. Sine's minimum value is -1. Sine can't equal 2. Okay. Focus. I got cosecant squared plus cotangent x. When does that equal 1? Oof. Now it's like, okay, I can set up something. I can set it equal to 1. I can subtract 1. And I have this. Again, this is like having an x squared plus a y minus a 1 equals 0. I don't know what to do here. I want to probably replace cosecant squared with what it's equal to. But it's like, what the heck is it equal to? Well, please go back a page and realize the following. The manipulations to this Pythagorean theorem in the unit circle are not limited to subtracting things. For example, what's cosecant the reciprocal of? Cool. Wouldn't it be nice if we had like sine in a denominator somewhere with this equation so I could turn it into like cosecant or something like that? Well, I want cosecant squared, so I want 1 over sine squared. I got a 1 right here. What can I do to make it 1 over sine squared? Yo, let's divide by sine squared. Now, let's look at what happens. I'd have sine squared theta divided by sine squared theta. I'm going to divide everything by sine squared. I'd have cosine squared theta divided by sine squared theta. And then I'd have 1 divided by sine squared theta. You see how I'm just taking what is the one thing you need to know and manipulating it. And this is what you got to be comfortable with, starting with this, manipulating by adding or subtracting, and now we're going to manipulate by dividing. Sine squared over sine squared turns into what? What does cosine squared divided by sine squared turn into? Tell your neighbor. Leifner, what does cosine over sine equal? What's cosine over sine, Leifner? What's that? Cotangent. What's 1 over sine squared? Cosecant squared. We just manipulated our Pythagorean theorem in our unit circle to be something that deals with cosecants and cotangents. You will be responsible for doing that. Yeah, I'll take it. Cool. No, it's all right. I'll take it. No, it's fine. It's fine. It's great. You can hang out with Linda too. All right, divide this equation by cosine squared. Tell me what happens to it. And then Woods will tell us all what happens to it. Go. Let's manipulate it one more way. Let's divide that entire Pythagorean theorem in the unit circle. You guys are horrible today. By cosine squared. Go. Leap year should be a holiday. February 29th should be a global celebration of the fact that it takes 365.25 days for the Earth to revolve around the sun. That just shows you how insignificant we are. We can't even get a whole number. Thanks, God. If you were 365.25. Listen, we should be doing more math that day.
You just said it's a global holiday.
It should be a global holiday where we're just realizing, like, 365.25, what a crazy, silly number. I didn't get really into it until right before I started teaching. I was more of a spreadsheet guy until I decided to be a math teacher. Good. Sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is secant squared. If you got that good, you are ready to manipulate your Pythagorean theorem in the unit circle. We got leap year this year coming up, February 29th. So, guys, here's the key. You will not have all of the manipulations memorized unless you're that kind of person who likes to memorize things. I have a horrible memory. I can't remember my kids' friends' parents' names. I call them like Wes's dad. I was like, hey, Wes's dad. Yeah, it's John. Like, not gonna remember that, but you'll still be Wes's dad next time I see you. Okay? So, like, you gotta have something to at least start with. At least I know the kid's name, so I go with that. At least you guys are gonna know that sine squared plus cosine squared equals 1, and then you can manipulate it. Here's Wes. Get Wes's dad. All right? Get what cosine squared is equal to. Yeah. And I think his name is Wes. I'm not sure. Wes or Wes. It's not a best friend. My son's best friends are Asher and Benny. Benny and Asher are my friends. You're right. You're exactly right. Just trying. My kid doesn't have any friends, you know. I'm just trying to keep this secret. Yeah. All right. So, how can I get cosecant out of that? I know divide by sine squared. Divide by sine squared. Divide by sine squared. Okay, here we go. 1 plus cotangent squared equals cosecant squared. Cosecant squared equals 1 plus cotangent squared. So, guys, you have to be able to start with something and then manipulate it. Don't memorize all the identities. It's not worth the time, and it won't stay with you. Instead, at least remember the Pythagorean theorem in the unit circle. Now, here's how you're going to be asked to practice this newfound knowledge. Besides solving these equations, you have the next page. We have 3 minutes, so Linda, you're going to help us out. We can practice all of the combinations manipulations through these questions. Simplify this expression so that it's equivalent to a single trigonometric function. Okay. We'll start, Woods, with 1 plus tangent squared. Woods, what is 1 plus tangent squared equal to? What's it equal to? You don't know either? Me neither. Okay, well, we'll start with sine squared plus cosine squared equals 1. And we will manipulate this so that we have a tangent squared. What would you like to do so that we end up with a tangent squared? What? Divide by something? If I divide by sine squared, I would end up with cotangent squared, so that's not good. So let's divide by cosine. Great. That gives us tangent squared plus 1 equals 1 over cosine squared is secant squared. You have to do this. That means 1 plus tangent is secant squared. I don't think this one works out, but whatever. If you have two secants being multiplied on the top and one on the bottom, one can be canceled. It should be sine on the top. Sine should be on the top. Now, if sine is on the top and secant's on the top, secant is equivalent to cosine in the bottom. All of a sudden, you get tangent. Yeah, you guys will practice all those. And you guys will probably think that you got it and you won't actually do the homework. And then you'll show up and you'll like to complain at the beginning of class. You'll be like, yo, I don't get this. And then we'll bomb the next quiz, just like we bombed the first quiz. It's been a great day today. Yeah, Matt, go ahead. No, you didn't. You didn't do the last three problems. You do the last